Next is the role of thermodynamic laws in pinch technology. You must know the thermodynamic law. So pinch technology presents a simple methodology for systematically analyzing chemical processes and the surrounding utility systems with the help of the first and second law of thermodynamics. So what is the first law? The first law of thermodynamics provides energy equations for calculating the enthalpy changes. So you must know the first law and second law. Enthalpy changes related in the streams passing through a heat exchanger. That is the first law of thermodynamics. That is same. Energy cannot be created, not be destroyed, but it can be transferred. Yes. In terms of second law of thermodynamics, it's the direction of heat flow from high temperature to low temperature. That is, heat energy may only flow in the direction of hot to cold. This prohibits temperature crossovers of the hot and cold stream profiles through the exchanger unit. In a heat exchanger unit, neither a hot stream can be cooled below cold stream supply temperature, nor a cold stream can be heated to temperature more than the supply temperature of hot stream. In practice, the hot streams can only be cooled to a temperature defined by the temperature approach. You already know temperature approach, range, latent heat, sensible heat, specific heat in heat transfer. It is a part of convection. So hot stream can only be cooled to a temperature that is nothing but the temperature approach of heat exchanger. The temperature approach is the minimum allowable temperature difference. That is delta T minimum in the stream temperature profiles for the heat exchanger unit. The temperature level at which delta T minimum is observed. Please listen carefully. The temperature levels at which delta T minimum is observed in the process is referred as pinch point or pinch condition. The pinch defines the minimum driving force allowed in the exchanger units. Minimum driving force allowed in the exchanger units. That is the pinch conditions. What processes does pinch apply? Pinch applies to a wide pinch originated in the petrochemical sector and is now widely accepted in mainstream chemical engineering. Wherever heating and cooling of process material takes place, there is a potential opportunity. Next is the benefits of pinch technology. Pinch tells the best that can be achieved in given system. Pinch gives the practical target to aim for that is less than this theoretical maximum. Both of the above are done before any detailed design. This target then set the basis for the design. There are multiple benefits for the pinch technology. The problem addressed by pinch technology. Now, this is the important part. Problem addressed by pinch technology. There are two problems addressed by the pinch technology. First is the creating new design, and next is the revamping existing design. Revamping in the sense of retrofitting. Retrofitting is nothing but the retro look, modified the existing plant, or you may design new plant with the help of process integration. मतलब पहले से ही आपको पता होना चाहिए कि आपको यहाँ पे प्रोसेस इंटीग्रेशन यूज करना है एंड यू हैव टू डेवलप वन न्यू प्लांट. ओके, मतलब यहाँ पे एक एस्पेन से एक बना लो, आपको फ्लोशीट बनानी है, देन यू हैव टू मॉडिफाइड दैट एस्पेन फ्लोशीट. कहाँ पे हीट एक्सचेंजर कम लगने वाले हैं, कहाँ पे ऐड करना है कंडेंसर, दैट यू हैव टू यूटिलाइज for developing new plant, or second is the retrofitting, revamping existing design. जो existing में है plant, उसी में कुछ changes कर सकते हैं क्या? So that is the cost effective, मतलब ज्यादा cost लगेगी उसमें. But new plant में अगर करो तो you can save the cost. The this is related in terms of creating new design. This is related to the design of heat exchanger network for a new plant, which is in design stage. That is the early stage. What about retrofit? Is related to the retrofitting of an already existing heat exchanger network in a plant to improve its exchange efficiency. अभी कहाँ से आपको heat exchanger निकाल देना है और कहाँ पे उसको फिट करना है. That is a part. बट कभी कभार कैसा होता है कि 3 हीट एक्सचेंजर रहता है और 2 ही आपको यूज करने हैं, तो एक हीट एक्सचेंजर का करोगे क्या? सो यू हैव टू उसको बेचना पड़ेगा वापस, बराबर. बट पहले से ही आपने वो लिया था, जब 3 हीट एक्सचेंजर लिए थे तो उसका कॉस्ट उसमें ये होगा, मतलब वहां पे कुछ ना कुछ आपका लॉस हो रहा है. व्हाट अबाउट न्यू डिजाइन? उसमें आपको पहले से ही पता है कि 2 ही यूज करने हैं वहां पे, सो यू मे परचेस ओनली 2 हीट एक्सचेंजर्स ओवर देयर. These are few examples for retrofitting and creating new design. So BASF, German-based company, has completed more than 150 retrofits. Please listen. BASF, German-based company, has completed more than 150 retrofit using pinch technology, achieving over 25% in energy saving site-wide. They save almost 25% of energy saving of the existing plant. But how much times? The 150 retrofit using pinch technology. Second example is in natural gas sweetening. For example, one another company is there, Ralph Caliph company is there, says that pinch technology led to 10% drop in capital cost and energy use in its amine absorption column. Another example is GE Plastics. GE Plastic was faced with a requirement of invest 15 million in doubling the capacity of the wastewater handling system of its silicones production facilities in Netherlands. So next part about the energy saving will cover in the next session, and this is the process in the slide number 23. It's a simple process with external energy source according to onion diagram. How you see that? Is the preheat the feed by use of one of the heat exchangers. रिएक्टर टेम्परेचर यहाँ पे 200 है, बराबर. सो हमारा फीड जो है वो एटलीस्ट 180 और 200 डिग्री सेल्सियस होना चाहिए. सो हियर आई यूज हीट एक्सचेंजर, बट प्रोडक्ट जो निकल रहा है रिएक्टर से उसका टेम्परेचर कितना होगा? वो भी उतना ही होगा, 200 के आसपास. सो इट्स द बेस्ट वे आई कैन यूज दैट हीट टू प्री हीट द फीड. यहाँ पे देखो शेल साइड में जो है उसको पास किया रिएक्टर प्रोडक्ट, एंड ट्यूब साइड में रिएक्टर फीड हीट होके गया, वो 150 तक होगा. तो मतलब अभी स्टीम के लिए, अभी यहाँ पे स्टीम कितना लगेगा? कम लगेगा. रिएक्टर फीड 150 है, 150 डिग्री सेल्सियस. नाउ यू हैव टू रीच अराउंड 200 डिग्री सेल्सियस. तो स्टीम कितनी? 50 डिग्री सेल्सियस की स्टीम लगेगी. बट इन जनरल डायग्राम में देखो तो स्टीम ज्यादा लग रही थी. फीड आपका 40 डिग्री सेल्सियस था और आपको रीच होना था 200 डिग्री सेल्सियस तक. दैट्स द